Hi everyone. Today we're going to learn how to add and subtract two or more radical expressions. So we're going to take what we've learned about simplifying radical expressions, we're going to use that, and then we're also going to combine radical expressions if possible. So I want to explore how we add fractions. In order to add fractions or subtract fractions, we need common denominators. This concept is going to be very similar to that of radical expressions, where if stuff is not common, we're going to learn that the index has to be in common and the radicand has to be in common. If not, we can't do it. So adding fractions with uncommon denominators, we were able to make common denominators. Common denominator is really nice, so we hope that's the case. We're going to hope the same case for radical expressions. So radical expressions can be added or subtracted together only if the radicand and the index are the same. So we're going to look at three examples here and see when we can combine them and when we cannot combine them. So the first one, the index is 2, the radicand is 3. We have 1 square root of 3 plus 4 square root of 3, and we get 5 square root of 3. We can combine them. It's kind of like 1x plus 4x is 5x. Now the second one, the radicand is the same, okay, both 2 inside the root, but here the indexes are different. So we cannot simplify that. In the third case, the indexes are the same. Okay, the indexes are both 2 here, but the radicand is 5 and this radicand is 7. So cannot simplify that one either. So we need very specific cases for there to be a simplification that we can do, or a combining of like terms. So here's some hints, things we should look at. First, take each radical expression by itself and simplify it. Use the factor tree, break it down, so we can get the simplest radicand possible, or the smallest radicand. Then we got to look at the index of each and the radicand. We got to check to make sure they're the same. And then we check our final answer, see if any more terms can be combined, or if we have different indexes and different radicands, then we're done. So here's the example we're going to look at. 4 square root of 3 minus 2 square root of 12. Now my first step that I would do is I would simplify 2 square root of 12. I'd use a factor tree. Okay, I'd pull out one pair of 2's from 12, so I'd have the original 2 times another 2 for the pair times the square root of 3. So 2 square root of 12 is 2 times 2 times square root of 3. I'd then rewrite the problem by multiplying 2 times 2 and getting 4 square root of 3. Then my original problem becomes 4 square root of 3 minus this new simplified version, which is 4 square root of 3. And 4 square root of 3 minus 4 square root of 3 is 0. Any number subtracted by itself is 0. So I simplified first. I then checked, okay, the index is 2, the radicand is 3, so we can combine them, and then we subtract the numbers out front. So 4 minus 4 is 0. And that's how you add and subtract radical expressions.